Hello there and welcome to our lecture discussion, and this is all about the properties and reactions of alkynes. To start our discussion, let's define first alkynes. So alkynes are hydrocarbons that contain a carbon-carbon triple bond. Now, how do we determine the chemical formula for alkynes? So we follow this general formula. So we have two formulas here. One is for acyclic, meaning it's linear, straight chain, and the other one is cyclic, meaning you have this enclosed structure. For acyclic, you follow CnH2n minus 2, and for a enclosed structure, naka-ring siya, so we follow the CnH2n minus 4, where N here is the number of carbons. Now, for the small cycloalkyne, the name is cyclooctane. So, octane siya, meaning 8. So, you have here 8 carbons, and then it is enclosed. So, we have also the presence of one triple bond. Now, let's ask the question, how do we prepare your alkynes? So, acetylene, the simplest alkyne, is produced industrially, meaning this is mass-produced from methane and steam at high temperature. As you can see here, this is the general reaction. So, specifically, it reacts, or this reaction proceeds at 1200 degrees Celsius. So you need two molecules of methane to produce one acetylene, or also known as your ethyne. The, the chemical formula is C2H22. Yan. So ito kasi ay, if we follow the general formula of CnH2n minus 2. This acetylene or ethyne is very important because it serves as a starting material for other organic compounds like acetaldehyde, and the other one is acetic acid. So you know this acetic acid as your vinegar. Another importance nitong acetylene natin na ito is this is the gas that is used and burned at high temperature oxyacetylene welding torches, di ba? So, when you're welding something like metals, then you use acetylene torch. And I can relate this to you as criminology students kasi if you heard of acetylene gang, this is a syndicate that robs banks. So, ginagawa nila ay tinutunaw nila yung mga metals doon sa perimeter ng bangko, so para mapasok nila. So, they use acetylene for that crime. Okay? So, alam niyo na. Another way of preparing your acetylene is by reacting your calcium carbide, o in Tagalog it's carburo, with water. So here is a representation of that reaction wherein yun nga nilagay yung calcium carbide is added to ice, then it produces acetylene. So acetylene is a flammable gas. That's why you can see here that it seems that the ice is burning. Okay. Now, what are another purpose of acetylene? So acetylene is also used for ripening your fruits and vegetables. So in our previous discussion of alkenes, we already encountered ethylene. So ethylene there is your plant hormone. Okay. So in this study of D et al., so calcium carbide is added to water to produce your calcium hydroxide, and then you have the production of your acetylene. And this is used for fruit ripening. So this one is an example or a picture of tomatoes that are ripened with calcium carbide. The next topic will be on nomenclature. But since I already discussed this last time, I will be skipping this. Okay? But I would like to emphasize here the terms terminal and internal alkynes. So when we say terminal alkynes, the triple bond is located or positioned at the end of the carbon chain. So, on the other hand naman is internal, the triple bond is located elsewhere, maybe in the middle of the chain. So, sige, i-discuss na lang din natin ng mabilis. For the naming of your alkynes, they're also named as substituted acetylenes. So that's the common name, okay? But if we follow the systematic name, then you need to locate the position of the triple bond and give it a lower number, okay? So an example here of a terminal alkyne is this one, 1-butyne, because the triple bond is between your carbon 1 and carbon number 2. So that is a terminal alkyne. For an internal alkyne, so the triple bond is somewhere along the chain but not at the end. So the one example is 2-pentyne. So the triple bond is between your 2 and 3 carbons of the chain. Okay? So the rules of nomenclature for alkynes, I will skip this all now kasi nga na-discuss na natin to last time. Now, I would like to focus more on the properties and reactions of your uh, alkynes. But in order to do that, we need to go back with the properties of alkenes. So, ang nangyari kasi, alkenes and alkynes, there are both nonpolar compounds. Diba? Because of the CH bonds natin. So, having said that, yung ating alkenes and alkynes, they also have similar properties. Their physical properties are similar. And yung alkenes and alkynes natin will be similar also with your alkanes with the same number of carbon skeleton. So, mapa 2 or 3 carbons man yan, if there are single or double or triple bonds, medyo nagkaka-similar yung kanilang mga properties. So, one notable na property ng ating mga hydrocarbons like alkenes and alkynes, they are insoluble in water. So, we know this because water is polar, di ba? Water is polar. Water is polar. Your alkenes and alkynes are non-polar. And we have a rule here na sinusunod natin, di ba? The like dissolves like. So, yung ating alkenes and alkynes will only be soluble in one another. For example, you add alkene and alkyne. Or your alkenes and alkynes will be soluble in any non-polar organic liquid. Okay? Okay. So, na-mention ko kanina that your alkenes and alkynes are insoluble in water. So, hindi sila mag-mix. And if alkenes and alkynes are liquid at room temperature and the density is less than 1.0 gram per ml, so what will happen? The alkenes and alkynes will float on water, just like this. Yan. So your alkene and alkynes and also your alkanes will float on top of your water because of the differences of their polarity. So nakikita natin dito, we have phase separation. So your hydrocarbons on top and then water on below. But if you mix your hydrocarbon with another nonpolar, so what will happen? They will readily mix with each other. Okay. The second important topic today is your reactions. So let's first recall your reactions of alkenes. So in our previous discussion kasi, na-discuss ko doon yung iba't ibang klase ng mga reactions like hydrochlorination o in general sense, it's called your hydrohalogenation. So halogenation kasi, we have the addition of your halogen. So halogens could be your chlorine, your bromine, and your iodine. Okay? We also have your hydration. So this means you have the addition of water. Halogenation. So addition of a halogen gas. and then we have your H2, so that is called your hydrogenation, or we also call that your reduction reaction. So why am I flashing this again? Because your alkynes will also undergo the similar reactions natin. Okay. But now, before I proceed with the actual reactions, I would like to again go back with the discussion on the preparation of your alkynes. So, here's a slide for the preparation, kung paano ba pine-prepare yung ating alkynes. So here, you have here an alkene. So this is an alkene, and then you subject it to bromination. So this is bromination, or in more general sense, this is halogenation reaction. Okay? So what will happen is, yung ating Br, di ba, the Br2 natin, it will split, and then it will react on the double bond. And the addition will be like this. So one Br here and another one here. So makaka-produce tayo dito nung tinatawag natin na vicinal dibromide or vicinal dihalide. So when say vicinal, your your halogens are located near to each other. So when say near it to each other, ano lang sila? Different carbons lang. At yung carbons na yun ay magkalapit lang. Okay? Now, sabi dito sa ating slide, the treatment of this vicinal dibromide, itong ating 1,2-dihaloalkane. So, di ba naging, ano kasi to, from alkene, naging alkane siya. Pero dahil meron ka nitong bromines dito or halogens, that is called haloalkane. Kaya siya di kasi dalawa yung halogen na nilagay mo. Now, if we treat this 1,2-dihaloalkane or your vicinal dihalide with KOH or NaOH, so this will produce a twofold elimination of your HX. So yung HX dito, yung X, that is your halogen. So itong KOH and NaOH, these are your bases. Bases yan. So mag-react siya dito sa ating compound. And magkakaroon tayo ng twofold elimination. We say twofold elimination ay sequential na maaalis yung ating HX. So in this case, ano ba yung HX natin dito? Itong HBr. So yung HBr, maaalis yan. Pero dahil itong ating HX kasi, the HX will react with your KOH. So what will happen? Magkakaroon sila ng palitan ng partner. So yung ating ito, so yung ating K, potassium, will react with the X, so that will become KX. And then yung H and OH natin, that will become water. So kaya dito sa reaction na to, nung itong vicinal dibromide natin ay inireact with the 2KOH, what happened ay yung HBr reacted with KOH to produce your KBr plus water. And since we have two HBRs here na pwedeng nating alisin, so times 2 lang yan. Kaya dito sa reaction ay nagkaroon tayo ng production of 2 water molecules and 2 KBr or potassium bromide. And what happened? Ito yung mas importante. Nagkaroon tayo ng formation nitong triple bond dito. Okay? The other one is through the use of this reagent called sodium amide with the presence of an acid. So, ano nangyari dito? Maaalis natin yung Cl and the H. So, this will become your HCl. And then, what will happen to the remainder of your compound? Magkakaroon tayo ng formation ng triple bond. Okay? So, again, treatment of this compound with KOH or NaOH produces a twofold elimination of HX, and vicinal dihalides are available. Ito. So, ito ay pwede mong ma-create ito from addition of bromine or chlorine to an alkene. So, ito yung pinakita natin. From an alkene, nilagyan natin siya ng bromine, then, ay nakaproduce tayo ng halo alkane. Okay? So, if itong step na to ay halogenation or bromination, so itong step namang ito, we call this your dehydrohalogenation. So, nag-alis kasi tayo. So, meron kasi tayong na-eliminate na HX. Yan. Okay? Now, for the reactions, ito na yung mas mahalaga. Now, iba-iba kasi yung reactions. So, madami siyang pwedeng i-undergo. So, one classic example nga nung sinasabi natin is yung halogenation. So, parang nabanggit ko na kanina. So, if meron tayong triple bond here, this will react with your X2, where X2 is either chlorine gas or bromine gas. And what will happen here is, meron tayong ma-attach natin yung ating halogen doon sa carbons. So from a triple bond, it became double bond, and then meron tayong addition dito nung ating halogen. And as you can see here, the addition is opposite siya. 'Di ba? So ito ay nakatrans yung kanyang orientation. Now, if you have another round of halogenation, what will happen ay itong ating carbon-carbon double bond with the halogens will react with the halogen, and then makakaproduce tayo ng yan. So, mag-attach yung halogen dito and we will form your tetrahalide. So, when say tetrahalide, apat, tetra, 4, and halide referring to the halogens. So, for halogenation is either chlorine gas or bromine gas yung ating ginagamit. So, let's give an example for that. So, this one is your reaction. So, meron ka ditong alkyne, and then mag-a-add tayo ng chlorine. So, attack siya dito. Yan. Kaya siya naging ganyan. And then, another round of chlorine gas. So, makakaproduce tayo ng tetrachloride. Yan. Okay? So, tetrachloride yung ating ma-form dito. So, from an alkyne, naging alkene, naging alkane. Actually, this is specifically an alkyl halide na. So, alkyl halide siya kasi we have a substituent that is halogen. Okay? By the way, if you want to do this reaction, your chlorine or your halogen should be nakalagay siya sa dichloromethane. So this one is dichloromethane. Okay? We have another example. So ito naman ay bromination. So ito ay bromination kasi Br2. Yung nauna kanina is chlorination because of the addition of your Cl2. So ganun din yung fashion nung pag-add ng bromine gas natin. So yung Br2 natin, mag-split yan, and then it will react with the triple bond. So yan, nakita nyo, opposite yung addition. And then another round of bromination in dichloromethane. So we will produce here your tetrabromide. So this is tetrabromide. Specifically, this is 1, 2, 3, 4. So this is met at prop but. So this is butane. And since we have tetrahalide dito, so this one will become 2, 2, 3, 3, tetrabromide butane. So that is the name of your compound. So try naming itong mga compounds natin dito. So dito pala may nakalagay dito na initial addition gives a trans intermediate. When say trans intermediate, ito siya. So the position of your halogens will be in trans. When say trans, this is opposite. And when say intermediate, this is a product, di ba? After nating i-react ito with chlorine, ito yung na-produce. But since this product will again react with another chlorine, so makakaproduce ka pa ng another product. So ito ang tawag natin dito is the intermediate. Okay? So that is for halogenation. So let's give another example. So ito naman is 1-butene. So 1-butene, yung ating triple bond ay nasa dulo. So this is a terminal alkyne. So a terminal alkyne, ayan, nag-react siya with bromine gas with in dichloromethane. So makaka-produce tayo dito nung trans na compound. Specifically, this is an E. So if you can recall our discussion on the essay nomenclature, so ito ay naka-E kasi siya ay yung high priority group sa atin dito, yung bromines, ay naka-opposite with each other. So another round of bromination for this compound will give you 1122 tetrabromo-butane. So again, consider the parent chain, so that's butane, and then let's start with the end na kung saan meron kang substituent agad. So dito, ito yung carbon number 1. This is 2, carbon 3, carbon 4. Kaya siya ay 1-1 dahil meron kang dalawang bromines attached on the carbon 1, and then you also have 2 bromines attached to the carbon number 2. That's why the name is 1122 tetrabromobutane. Okay? Now, let's go to hydrohalogenation. When say hydrohalogenation, you add here hydrogen and something halogen. So, this is the general reaction. So, you have your triple bond reacting with a hydrogen halide. So, the HX is a hydrogen halide. And that could be HCl, HBr, or HI. So, what will happen ay, yung ating HX, it will separate with each other. So, maghihiwala yan, and then it will react, the H will react on one carbon or will attach, and then the halogen will attach to another carbon. And if we have another round of HX addition, ay magkakaroon tayo ng formation ng tinatawag natin na geminal dihalide. So bakit siya geminal dihalide? From the concept, kung familiar kayo with the constellation Gemini. So Gemini means twins, di ba? Yung positioning ng ating halogens ay on the same carbon. That's why it's called a geminal dihalide. Okay? So dihalide siya kasi bakit? Dalawang halogens lang yung ating naka-attach. Okay? So yung fashion pala nung pag-add ng HX ito do sa second addition, di ba? Maghihiwalay ulit yung ating H and the X. Di ba? Magsisplit yan, makakat yan. Yung H natin will attach to the carbon with more hydrogens. So since dito kumabit yung ating hydrogen, so the hydrogen will attach here and the X will attach to the other carbon. That's why we will always observe the formation of this geminal dihalide. So let's give an example. For example, this one is 2-butene. So 2-butene siya. So this is 2-butene. So 1, 2, 3, 4. And then the triple bond is between 2 and 3. So if we add HCl, so dito kumabit yung ating Cl. Ayan. And then dito kakabit yung ating H. So lagay natin. So that's why the intermediate looks like this. So this is your 2-chloro butene. So yung double bond natin is in 2 and 3. And the chlorine atom is attached on the carbon number 2. So if you have another round of HCl addition, yung Cl will attach here and the H, dito siya, mag-attach yung Cl, and then the H, the other H will attach here. Kasi merong itong H na naka-attach. So if you recall in our discussion, this is Markovnikov addition. So when say Markovnikov addition, the H will attach, or add to the carbon with more H attached to it. Okay? So let's give another example para mas clear. So this one is HBr addition, hydrogen bromide. So if you have one hexane, this is a terminal alkyne siya, yung ating H will attach here. Yung sa Markovnikov kasi, ang tinitingnan natin is yung carbon. At tingnan nyo doon kung yung bang carbon na yun ay mas madaming H na naka-attach. So ito ay naka-attach dito sa buong ito. Pero hindi naman yan hydrogen. Itong carbon na to, naka-attach siya sa isa. So dito, mag-a-attach yung ating H and dito naman a-attach yung ating Br. Kaya ito yung ma-observe natin. And the name is 2-bromo, 1-hexene. Now, if you have another round of HBr addition, dahil itong carbon na to, meron na siyang dalawa na hydrogen, so dito pa rin mag-attach yung isang H natin. Kaya, ganyan. And then the bromine will attach here. So that's why it's called now your 2,2-dibromohexane. Now, for this one, this is an internal alkyne naman with the addition of HCl. So dito, natin mo observe yung meron tayo ng trans na intermediate. Okay? So when say this is say, kasi yung high priority groups natin is Cl here, di ba? Nung ating discussion ng alkane. So Cl is high priority and this part is also high priority. So if your high priority groups are on the same side, so that is a say. So that's why it's called say 3-chloro-3-hexene. Now if we have another round of HCl addition, the H will attach here and then the Cl will attach here. Kaya siya naging ganito. So this is called your 3,3-dichlorohexane. Okay? So always recall your Markovnikov rule. So Markovnikov rule means yung H natin will add to a carbon with more H attached to it. Okay? So the more H you have, yung carbon na yon, then mas dadagdagan pa siya ng H. So another rule is the rich gets richer. So the more hydrogens, it will add more hydrogens to it. Okay? So ito naman, kakaibang example ito kasi ito ay internal alkyne and mangyayari kasi dito ay meron tayong two possible sites of addition. Kasi ito, pwedeng dito mag-add yung hydrogen. And then this one, dito yung Cl. Okay? And then, kapag nagtuloy-tuloy na yon, this will become yung another H natin dito mag-attach and then dito yung Cl. So, ito yung katulad nito. Yan. But if itong compound natin na 2-pentyne, dito mag-react, palitan natin yung kulay. So, if dito mag-react yung Cl, and dito yung Cl, and dito yung ating H, so yung another round of HCl addition natin, yung H dito naman mag-attach, and then the Cl will attach here. So, kaya ma-observe natin dyan is yung Cl ay nasaan? Nasa third position. 1, 2, 3. So, ito yung mapoproduce natin. So, ang ano lang dito is, if you have an internal alkyne like this, meron tayong mixture. We have a mixture of your geminal dihalide. So, anong difference lang nila is the position. The position of the halogens. So, ito, the chlorine atoms are located in the second carbon. So, ito ay geminal ha. This is geminal dihalide kasi nga, siya ay, yung ating halogens ay located on the same carbon. Okay? Ito naman ay 3-3 kasi if we count it, 1, 2, 3 or from other way around, 1, 2, 3. So it's in the third carbon position. Okay? So I hope everything's clear. We'll proceed now with the third reaction. This is called your hydration reaction. So hydration reaction refers to the addition of water. So wag malilito kasi meron tayong term na hydration, hydrogenation, halogenation, and dehydrohalogenation. So may mga term tayong gano'n, wag malilito. So in this reaction, etong triple bond natin will react with the water in the presence of your sulfuric acid and this mercury compound. So the mercury compound here serves as your catalyst. So the catalyst here will speed up the reaction kasi without the mercury to sulfate ay sobrang bagal nitong reaction to. So what will happen ay meron tayong formation nitong tinatawag na enol. So ito ay yung tinatawag natin na enol compound. So bakit siya tinawag na enol? Kasi it comes from the word in and ol. Yung in is the double bond and the ol for the OH. Okay? Kaso, itong enol compound na to is very unstable, kaya it will go or undergo rearrangement reaction in such a way na yung ating structure will become a ketone. So napansin nyo dito, the COH, it became C double bond O. And what happened to the H? Inilipat siya dito sa kabila. And what happened to the double bond? It became single bond between the carbons. Okay? So itong compound na to, depende pa yan kung siya ay nasa dulo or nasa sa middle. So this could be a ketone or an aldehyde. So please remember your functional groups. So let's give an example. So this one ay yung ating compound. Yan, this is 1, 2, 3, 4. So 2 butane with the addition of water, with the presence of sulfuric acid, and also your mercury compound. So ang mangyayari dito, explain natin, magkakaroon tayo ng formation ng enol. So let's say that dito mag-attach yung OH, yan, and the other one is dito yung H. So ito magiging double bond siya. Ngayon, enol natin, magkakaroon nga siya ng rearrangement reaction. So, itong OH will become C double bond O, tas yung H ay malilipat sa kabila. So, what happened? Yung double bond, magiging single bond dito. Yung dating CH lang, naging CH2 kasi the H from the OH ay inilipat dito sa carbon na to. Okay? Kaya siya naging ketone. So itong process na tinatawag natin na to, yung enol and ketone interconversion is what we call your tautomerization uh, process. So yung ating keto tautomer kasi, this is more stable kaysa dun sa enol. The enol here is very unstable. Yung keto tautomer natin is more preferred. So more preferred ng compound na nasa keto, ano siya, yung kanyang structure, keto. Okay? So another round of examples. So ito, katulad lang siya nung sa ating nauna. Okay? So let's yan, isa-isahin natin. So dito sa part na to, let's say dito siya mag-react yung OH. Dito mag-attach and then dito yung H. Yung water kasi natin, 'di ba? HOH, 'di ba? So mag-split 'yan, yung isa magiging H, yung isa OH. So saan natin ilalagay yung H and then the other one is OH. So yan, ganyan yung itsura niya. Ngayon, ito magiging CH3, CH2, C, OH, double bond, C, H, CH2, CH3. Itong part na to will become a double bond, O. So, C double bond O, CH3, CH2, and then, ito magiging single bond, C, and then this part, CH, magiging CH2 na siya. Kasi nadagdag dito yung H na ilipat. Yan. And then CH2, CH3. So, parehas ba? CH3, CH2, C double bond O, CH2, CH2, CH3. Yan. So, ganyan yung magiging itsura niya. Ngayon, ito medyo complicated siya kasi magkakaroon tayo ng dalawang possible na products. So, ganun lang din ulit. If dito mag-a-attach yung OH, and then dito yung H natin, ito magiging double bond. Yan. So, ito, later on, magiging C double bond O. And then, yung double bond natin kanina dito, magiging single. And then C. And then, di ba nilagay yung H originally here? Yung H from the OH, dito lilipat. So, ito, pag ganito yung addition, ito yung first natin na product. But, if we add the OH doon sa third carbon dito, so magiging C, dito yung H, double bond, C, this is OH, ayan. Then, ito na yung rest nung ating compound. So, what will happen ay itong COH dito, magiging C double bond O. Yan, C double bond O, C. So, yung double bond here, naging single. And then, yung H, originally naka-attach dito, madadagdagan pa ng H dito. Yan. Kaya siya magiging CH3, CH2. This is the C double bond O, and then CH2, CH3. So, ito yung mapoproduce natin, the second compound. Okay? So, this is an internal alkyne. Internal siya kasi yung ating triple bond ay somewhere along the chain but not at the end. Kasi yung ating original kanina, internal din naman siya pero kasi ang sana napansin niyo dito, ito kasi ay um, symmetrical siya. When say symmetrical, yung pag tinupi mo kasi yung compound, magkapareha sila nung tupi. So, i-fold mo dito sa part na to. So, di ba C, CH2, and then CH3. Pero dun sa ating another example here, hindi siya symmetrical. So, this is symmetrical and unsymmetrical internal alkyne. So, pag unsymmetrical internal alkyne, meron tayong formation ng dalawang products na ketone. Yan. Okay? Paano naman kung terminal? Kung terminal alkyne siya, with the same procedure, yung ating addition of water with sulfuric acid and then mercury to sulfate. So, makaproduce pa rin tayo ng enol, but this time, yan, ketone pa rin yung mapoproduce natin dyan. Okay? So, paano yung process dito? Yung sinunod ng water dito, nung H and OH natin, so, dito nag-attach yung H. Yan. And then, dito yung OH. So, ito magiging double bond na lang. And then, the OH here, the COH will become C double bond O. The double bond will become single, and then C, and then lilipat yung H na inalis natin doon sa OH. So, magiging ganyan siya. That's why, magiging ganito siya. Yan. So, from enol, yung kaninang enol natin, enol siya kasi nga may double bond and the alcohol, in and the ol, enol, nagkaroon siya ng tautomerization, naging ketone siya. Okay? So, ganun yung nangyayari dun sa terminal alkynes natin. Pero, merong isang set ng reagent na kapag pag ginamit natin siya, so ang tawag dito is yung hydroboration oxidation reaction. So, gumagamit dito ng uh, may boron compound ka. So, yung boron is yung B. And then, may presence ka rin ng water, hydrogen peroxide, and base mo. Ang mangyayari dito, imbis na ketone yung na-produce mo ay aldehyde. So, ano nangyari? Yung kasing ating reaction ng water with sulfuric and this mercury, nagpa-follow pa rin siya ng Markovnikov style of addition ng H. Di ba? Dito mag-attach yung H, kaya siya naging CH2, and then dito yung OH. And then magkakaroon ka ng rearrangement, kaya magiging ketone yan. Ngayon, dito sa isang set ng reaction, yung may dicyamyl borane, nasa yung aking ano, and then the water, hydrogen peroxide, and the OH minus, ang mangyayari baliktad, yung H ay mag-a-attach dun sa mas kakaunti. So, ang tawag dito is yung anti-Markovnikov. Markovnikov na addition. So, anti-Markovnikov. Kasi when say, di ba Markovnikov, yung H will attach to the carbon with more H. But since this is anti-Markovnikov, the H will attach to the lesser, yung carbon with the lesser hydrogen. So, this part yon. So, ibahin natin yung kulay. This part, dito mag-a-attach yung H, and dito sa part na to, mag-a-attach yung OH. Kaya naging ganito. Yan. OH on the first carbon, and then H here. Diba? CH3, CH, nadagdagan ng H dito, and then CH, and then the OH is here. And this part will rearrange again. The COH will become C double bond O. Yan. Kaya siya naging C double bond O here. And here's the H. Ito yan. What happened to the H na originally nandito, na ilipat siya dito. Yan. Kaya siya naging aldehyde. Okay? So, using this reagent will create an aldehyde instead of a ketone. Now, we go to addition reactions pa din, but this time, we call this your hydrogenation. So, when say hydrogenation, this is the addition of hydrogens. So, what I'm showing here in this slide are just the general reactions. So, you have your alkyne, your triple bond. The first reaction is, meron ka nung two hydrogen gas, in the presence of your nickel, platinum, or palladium on carbon. So, yung ating metals ay nasa surface ng carbon. It will result to the total reduction. When say total reduction from an alkyne, mag-proceed siya into becoming an alkene, and then eventually it will become an alkane here. So that's why it's called a total reduction. Nagkaroon ka ng from triple, it will become all single bonds here. Now, if you have naman sodium metal or lithium metal in liquid ammonia, ang ating H, 'di ba kasi hydrogenation to, H2. We add H2 gas, the H will split. So yung H natin will have a preferred na addition. So maghihiwalay nga yung H natin into yan, H, and it will attach to the double bond. Kasi itong triple bond, it will become double bond here, and we call that your anti-addition. So yung H nandito sa isang side, and the other one is on this side. So it is anti-addition kasi nga there are opposite with each other. And we will form here a trans-alkene. Bakit siya trans-alkene? Kasi the groups are on the opposite side of the double bond. But if you use here H2, hydrogen gas, with Lindlar catalyst, so yung Lindlar catalyst natin dito ay, this is palladium din on carbon, calcium carbonate. So, calcium carbonate yung, yung surface. Palladium on calcium carbonate. So, what will happen naman is, we call that your cis alkene. So, yung addition ng H natin is yung syn. When you say syn, this is same. Same side of the double bond. So, anong pangalan ng ating alkene dito? This is a cis alkene kasi nga on the same side siya. So, let's give some examples lang para mabilis lang. So, ito ay ang ating 1-butane. So, this is 1-butane with the presence of hydrogen gas in platinum and on the surface of carbon, it will become butene. And then another round, it will become butane. So, ganun lang siya kadali. So, magdadagdag ka lang ng H dito. Yan, H, H. Hanggang sa lahat ay maging single bond siya. So, this is also called your catalytic hydrogenation. Kasi bakit siya catalytic hydrogenation? The platinum on carbon serves as your catalyst. So, it will speed up the reaction. Now, for the other one, yung ating may Lindlar catalyst. So, yung Lindlar catalyst natin, yung may palladium, this is palladium on calcium carbonate, it will result to the formation of your cis alkene. So, bakit siya cis alkene? Kasi yung addition ng ating H will be on the syn addition fashion. So, we say syn on the same side. Okay? Yan. So, from 2-pentyne, so this is 5 carbons, the triple bond is between 2 and 3. And then, if you undergo Lindlar catalyst with hydrogen gas, so you will form cis-2-pentene. For the third example natin, ito naman ay kapag gumamit ka naman ng sodium or lithium metal on your liquid ammonia at negative 78 degrees Celsius, the addition will be trans. So, yung ating addition ng hydrogen will be anti-addition. So, when say anti-addition, opposite yung addition nila. Yan. So, what will happen? We will form a trans. When say trans, the similar groups are on opposite side of the double bond. So, from 2-butane with this reagent will form your trans-2-butene. Okay? Last two slides natin is on ozonolysis. So, this is also called your oxidative cleavage. So, when say cleavage, you are cutting. You are cutting the molecule. Okay? And oxidative, kasi you are using here oxidizing reagents. So, strong oxidizing reagents such as O3, this is ozone, yung ating nasa ozone layer, and or KMNO4, this is potassium permanganate, will cleave internal alkynes. So, when say internal alkynes, the triple bond is somewhere along the chain. So, what happens? Yung compound natin will split into two. And that's not the end of the process kasi after mag-split yung molecule natin, it will produce 2 carboxylic acids. For a terminal alkyne, yung terminal, ibig sabihin nun, the triple bond is at the end of the molecule, like this one, it will produce a carboxylic acid and a carbon dioxide. So, let's illustrate. So, ito yung triple bond natin, this will be cut. Yan. So, i-cut na natin siya for internal and the terminal. Ngayon, simulan muna natin dun sa ating internal alkyne. So, this part, Yan. So, makakat yan. Pansinin niyo yung R and dito may R prime to. So, itong part na to, yan, magkakaroon siya ng double bond O dyan, and this part will also have OH. And then this part will become C double bond O and then OH. So, pag kinat mo na siya, mag-oxidize siya. When say oxidize, mas dadami yung oxygen doon sa molecule. Kaya napansin nyo ay mas madami yung oxygen dito. Yan. So, magkakaroon ka ng dalawang carboxylic acid. And I hope you're still familiar with your functional groups. This one is a carboxylic acid, C double bond OOH. Okay? Pero pag terminal alkyne yung ating pinag-uusapan, ganun din, magiging ito, magkakat yan. This will become C double bond O, and then ito magkakaroon siya ng OH. Ito, CH na lang siya. So ito, hindi na magiging CO yan. Pero dahil ito ay magiging kulang yung ating sa octet natin, this CH will become COO or your carbon dioxide. Yan. So ano lang yung point dito? Pag hindi mo alam kung nasan yung posisyon ng iyong triple bond, you can do this ozonolysis or oxidative cleavage to determine which alkyne natin ay terminal or internal. Okay? For the last slide natin is itong all about the commercial use of ethyne. So I mentioned earlier na itong ethyne kasi natin is a precursor or a starting material for a wide variety of organic compounds pa. And your ethyne could be used for formation of your plastics. Okay? So one classic example natin ng plastic is yung tinatawag natin na PVC or polyvinyl chloride. So paano lang ba yung kanyang reaction? You have your ethyne here reacting with hydrochloric acid to form this vinyl chloride. Ngayon, this vinyl chloride, this will serve as your monomer. So when say monomer, this is your starting material or building blocks. So building blocks natin yan. These monomers will undergo polymerization. We see polymerization, hahaba siya. Yung madami kang vinyl chloride and then they will connect with each other and that process is called polymerization. So kapag nangyari yung process na yon, ayan, magkakaroon ka ng tinatawag na poly kasi nga siya ay nag-polymerize, humaba siya, nagkabit-kabit sila lahat. So that is now your polyvinyl chloride. So ito yung material na nakikita natin sa mga tubo ng ating tubig. The other one is iba yung reagent. This one is hydrocyanic acid or hydrogen cyanide. It will form your acrylonitrile. And then same process, ito will serve as monomer or building blocks natin. It will react with it will polymerize, hahaba siya. So it will become your PAN or the polyacrylonitrile. So ganito yung itsura nung PAN, mukha siyang fiber, mga parang bala-balahibo siya. Pero ito ay ginagamit on a wide variety of materials din. Okay? So, ayan, na-discuss na natin yung properties, kasama na din yung mga important reactions ng ating mga alkynes. And that ends my lecture discussion. Thank you very much for listening.